In this section, I'm going to start a discussion on TCP Intercept. First of all, I want to give you a reminder, a refresher on TCP connections, and then I'm going to talk about a situation in which an attacker tries to use all our resources, and that's called a SYN attack. So I assume that there is a server in my network. This is an FTP server, for example. There is a client on the other side, an internet, that tries to connect to my system and tries to download a file from my server. So the first thing is the client sends a request to my server. Because this is going to be a TCP connection, the first phase is to send a synchronization request. So this is a SYN request from client to the server. The server replies with an acknowledgement. And this acknowledgement means that the client is acknowledged, the synchronization is done. So this is an acknowledgement message. And also, server should synchronize with the client, so it sends a synchronization message as well. The other side, that is the client, replies with an acknowledgement to the server, and that's an ACK message actually. And then the TCP connection is created. So this phase has three messages. So it is called a three-way handshake. Handshake, and my handwriting is shaking as well. So we have three-way handshake. The result of a three-way handshake is an established connection. You see the status as established for this kind of connection. We have some other messages as well. Well, for example, we have reset messages, that is called RST messages. We have fin messages, that is the finish message, finish the connection. We have other types of messages, but these are the most important. So basically, when a connection is created, server gives some of the resources, gives some of its resources to this connection. Perhaps an amount of memory, a port number, CPU process, and any other resource that you can think of. It should be allocated to this TCP connection so that the TCP connection is up and running. So I assume that there is a problem. And this problem is this. The client sends this synchronization request, and the server replies back. The server has allocated the resources, the port number, the memory, or anything. But the client never sends back the acknowledgement. So this is a half-open connection, or what is called semi-established connection, or something. I don't know the exact word for that, but I know that is half-open connection. A half-open connection never goes to established mode because the client is never sending the acknowledgement. So the server's resources is allocated to this connection, the connection that is not gonna work. So assume that the client sends a lot of synchronization messages to the server, and server sends a lot of acknowledgements back to the client. So server is allocating almost all its resources to the connections that are half open. This is called a SYN attack. In this type of attack, an attacker tries to deplete all the resources on the server. So the server is going to be unresponsive to any other client. The server cannot respond the other requests. So how can we stop this? How can we make sure that we are not going to be a subject to a SYN attack? One of the features that is implemented in Cisco routers is called TCP Intercept. And in TCP Intercept, what happens is this. Let me assume that my server is here, and I'm going to make it a little thicker, and a client is here. So the client's normal path to reach to my server is going to pass router 2, and router 2 is going to send the request to server. Server is going to send the replies back to router 2, and router 2 is going to forward it to the client. And this is where traffic comes and goes. So we can implement a feature on this router. The feature says whenever I receive a TCP synchronization request, a SYN request from a client, that is this and this is a server, when a client tries to send a request, this is a client and this is a server. Client sends the request, a router 2, for example, here sees the request. So router 2 does not forward the request to the server. Instead, router 2 is going to acknowledge the synchronization request and sends an acknowledgement and a SYN to the client. The client has already sent a synchronization message. So if the client replies with the third message, that is acknowledgement, then the router knows that this is a rightful TCP connection. So router is going to create a TCP connection to the server. So server replies and router replies. Router has a connection to the server. A router has a connection to the client. Client and server communicate without even knowing there is something in the middle of their connection. So the router is going to act as a proxy here, and it is transparent. So you know that this router here governs every TCP connection that is created between the server and client, and actually router is creating the TCP connections, and if it feels that there is a problem with the connection, it is not even going to bother the server. So this is the feature. Now in next section I'm going to talk about the commands to enable TCP intercept feature. Now let's talk about the configuration of TCP intercept. First of all, I need to define a list of servers. These servers are in DMZ area, so the IP address for those servers is 10.10.23.0/24. These are going to be protected by my router that is going to act as a firewall in between, router 2. So first of all, what I need to do is to create an access list that contain these lists of servers. These are going to be my destinations. The sources are in another part of the network, for example internet. They are going to establish a connection to the servers, and I'm going to protect the servers. So let's go to router 2, and first of all I define an IP access list, and its name is servers subnet, and that's going to be an extended access list. So I type ext here, and I'm permitting, because I am including any protocol, I just type IP. Actually, you know that this is going to include only TCP, but I just typed IP because this is inclusive. It includes everything. So permit IP from any source to this subnet. The subnet was 10.10.23.0, and that's going to be 0002255. Hit enter. That's it. Next thing, I'm going to enable IP TCP. So I exit, and first of all I want to show you some options here. If you type IP TCP, you can see that we have a lot of options. TCP intercept is what I am going to talk about. So I just type IP TCP intercept, and there are a list of items, and some of them are a little vague, and I'm going to talk about that. First of all, you should know that the connection has a timeout, but this timeout should be small. You should not create a big timeout. This means that if you have a long timeout, the connection is going to wait for a long time before it is discarded. So what I'm going to do is to make sure that it is 10 seconds or 15 seconds based on the round trip time that I normally know about my network. I know that my connection is a little fast. I give the other side some time to reply, but if it fails to reply, or if it doesn't reply intentionally, I'm going to discard the connection. So I believe 15 seconds is plenty. The next thing is max incomplete. How many incomplete connections do I allow to be created? Normally I do not go higher than 100. I mean, if there are more than 100 connections, I'm going to drop some of them. And I drop them randomly, or I drop them based on the old to the new. You see there's a drop mode here that says you can drop some connections randomly, or you can drop the old ones first. I prefer the old ones first. So it says if you have a lot of incomplete connections or half open connections, you are going to drop them. So max incomplete says how many connections should be there so that you start dropping them. I assume 100 is plenty. And there is something else here. 1 minute. I say, okay, I will accept as much as 100 incomplete connections, but I'm not expecting to receive all those incomplete connections in 1 minute. If I receive 100 incomplete connections in 1 minute, or even more than that, I believe that there is a SYN attack. I guess there are about 20 incomplete connections or 10 incomplete connections in a minute acceptable. More than that is not acceptable. So max incomplete says the total number of half open connections, but 1 minute says an average of this number should be created in 1 minute. More than this, I suspect there is something going wrong with my network. So I need to configure both of these. So first of all, I type max incomplete. The max incomplete has a high number and then has a low number. The high number says from this I'm starting clamping. I start dropping the connections, and I assume that this is about 100. Okay, but the low number, it says first of all you should configure low number. So let's go for low number first. It says if we have as low as 60 connections that are incomplete, we are not going to drop anything. That's okay for us to have 6 of that. Let me see, what is the next? High is going to be 100. So if we have less than 60 incomplete connections, we are not doing anything. If we have more than 60 but less than 100, we are going to drop some random incomplete connections. But if we have more than 100, we are going to drop all of them. We are not going to let any one connection more than 100. 100 is the highest threshold here. Okay, so as I told you, we need to configure for 1 minute as well, because that's going to be our average. So I type 1 minute, and for 1 minute again I have low and high. I'm going to set low to 10 and set high to 15, for example. I assume that I have an average incomplete connection in every 4 seconds. Okay, now the rest of the configuration again are important. First of all, you should say that this IPTCP intercept feature is for these lists of servers. So the list is going to be the access list, and as I told you, the list of servers name is servers subnet. So I hit enter. Now I have configured IPTCP intercept for any connection that matches these this access list. And the next thing, as I told you, is connection timeout. So I type connection timeout, and you can see that connection timeout can be a long time, or as low as 1 second. As I told you, 15 seconds is okay for me. And on the drop mode, I can go for drop mode, and as you can see, the oldest and the random. I'm going to use oldest because I believe the oldest ones are the worst ones. Okay, now I am old, of course, and the world TCP Intercept is going to catch me as soon as possible, but right now this is a configuration for TCP access list. So let's go through the configuration. Let's show the running config and see what we have done. We have IP TCP Intercept. Let me see what I have here. We defined a list. We changed the connection timeout. We changed the TCP intercept maxing complete, and we configured the low and high threshold for that, and also we configured that for 1 minute. And because the mode was oldest by default, you don't see any command for selecting the oldest. Okay, it's time to check this configuration. So let's go to router 4, for example, and try to telnet 10.10.23.3 on port 20, for example, or even telnet, because telnet is a kind of TCP connection. And before that, I need to go to router 2 and start a debug. So I go here, and first of all I want to save the configuration, and then I'm going to start a debug. Debug IP TCP, I believe there is something for this. IP TCP Intercept, yes, that's it. And hit enter. So let's go to router 4 and initiate the telnet. Now you can see that it goes to router 3, and there is going to be a username and a password. Let's go to router 2 and see what happens. It intercepted a new connection from 1124 to 54. You can see the SYN message sent to 10.10.23.3 on port 23, and this sent back an acknowledgement and a synchronization, and this sent synchronization. Now you can see the connection is established. This is very nice. The connection is established, so there is nothing wrong with the connection. After some time, you see that the message reset is sent because router 4 did not start the telnet connection because it didn't enter a username and password in a timely manner. It doesn't matter. The telnet connection was created. We saw the TCP connection here, and everything was just fine.